Good afternoon, everybody. Welcome in this deep dive session regarding Kubernetes and how to secure a Kubernetes cluster. We are very excited to be here with you today at DevOps Belgium. We're going to start by introducing ourselves. And today we have three speakers from France, so we can call them the Musketeers. We have Marion, Vincent, and me, Ludovic. Marion, would you like to start?
Yes. Probably with the mic it would be better. Can you all hear me? That's good. Great. So my name is Marion Nicolé. I currently work as a technical leader at Capgemini in Paris, well, around Paris. And what I do in my daily life, my daily working life, is that I administrate Kubernetes clusters. So I have some on-premise Kubernetes clusters, cloud-managed Kubernetes clusters, and what I especially do is that I'm deploying on those all the Kubernetes stack you can imagine. So all regarding observability, authentication, authorization, and security aspects. And that's what we're going to talk about today. I especially deploy a tool which name is OpenPolicy Agent, and that allow to do fine-grained governance on the cluster. I will present that to you on the second part of the talk.
Hi everyone, I'm Vincent Bodiou. I work in Paris as well in Capgemini in the cloud and custom application practice. And I'm a Java lover, and I work with Kubernetes for 3 years now. And I got 2 certifications on it, the application developer and the administrator one. And yeah. Just before we start, I just want to thank 3 persons who helped me to prepare this talk in English. Jean-Sébastien Vinals, Emilian Oslo, and Caroline Ball.
Cool. And I'm Ludovic. I'm working as a head of engineering in NFQ Asia. It's a company that is located in Vietnam, in Thailand, and Egypt, and we are mostly supporting European customers. And over the last couple of years, I have been working as a technical architect in different organizations to support setup, building, and operating Kubernetes cluster, including side projects like Istio and OpenFaaS. All right? As a starter, as a beginning point, in order to move forward, I would like to start a small survey in the room. And I would like to ask you 3 questions. The first question I would like to ask is, how many people are using today Kubernetes in production? If you can raise your hand, it could be great. Okay, so most of you, we have probably nearly 90% of the room who is using Kubernetes cluster in production today. Okay, cool. The second question is, among these people, how many are using cloud provider and especially Kubernetes managed services? Again, raise your hands, please. Okay, a little bit less. I would say that, yeah, maybe 60%. Okay. And the final question would be, among these people, how many have already taken a look pretty deeply on the security aspect of Kubernetes? Raise your hand if you have already opened the doc or like check stuff. Okay, cool. So all of these just to understand that Kubernetes security is quite tricky but quite interesting as well. And why that? The first thing that we need to understand is that when we operate Kubernetes cluster, by definition, we enlarge the attack vectors, because previously, when I was running my little virtual machine and I was running my application, I have this very strong isolation. But now that I have container runtime, I have my Kubernetes cluster, I also running containers, I introduce different layers, and all of these layers can introduce possibly a vulnerability, meaning I expose a little bit at different level. This is something we need to understand and which is complex. The second aspect is, by definition, Kubernetes with all the components that is running to serve those services. We have different components. It's a master-slave architecture. Then, again, it's pretty tricky to operate, to secure, because many services are exposed, different ports. We need to handle the authentication. We need to patch those services. Pretty challenging as well. Finally, what are we running on Kubernetes? A set of workloads, a set of images, and these images, of course, could contain possibly vulnerabilities, especially if I'm not building from scratch my own images. Most of us, I'm sure, are using public images. We can't fully be sure that they are great. So it's a very kind of old survey regarding the number of vulnerabilities inside images. But this is just to understand that, yeah, we need to treat there carefully. Okay? When we have said that, what can we do? Basically, we have a set of attack vectors, we have a set of threats, and by this kind of matrix analysis, we can identify all the threats and try to solve these by using either the primitive exposed by Kubernetes or either relying on some extra features that we are going to demo today. Okay? During this presentation, 3 main principles will guide us. We are not reinventing the wheel. We are just reusing existing security principles, and we are going to try in the next 3 hours to apply them in the context of Kubernetes. Least privilege, defense in depth, and surface attack reduction. Over the last couple of years, we have operated and built many Kubernetes clusters in various environments. Big data, very standard workload with web apps, and also some industrializations tool, like how we could run a GitLab inside Kubernetes, or we can run Kafka in Kubernetes. And in all these projects, customers challenge us regarding how it is secure. And then what we would like to do today is to share with you the approach, the principle, the tool we have used to solve these issues. And the first step would be to start by looking at what is Kubernetes and how is it being configured. And to think about that, again, when we look at the Kubernetes architecture, master-slave architecture, we have different components, exposing ports. Most of these components, they run as privilege, okay? And they do very advanced operation on the machine, of course, because they need to open the network, they need to manipulate the file systems, and how can we make sure that all these components are correctly configured? There is a very nice documentation that is produced every year by the CIS, which is called Kubernetes Benchmark. And in this benchmark, you basically have a definition of all the vulnerabilities and all the checkpoints that you have to comply with for running a production Kubernetes cluster. So it's quite nice, but again, pretty heavy to read, and this is where Vincent will now show us a tool that will save some time.
Yeah, thanks, Ludo. As you said, that's an interesting book, but not the funniest part. So thanks to Aqua Security, they made a tool for us named KubeBench. And KubeBench is gonna check your statically your technical configuration of your cluster. It's written in Go. It has a good community, like 5,000 stars and more than 100 contributors. And what it does, it will check if all the files we need to be protected are well protected. If you have some expired certificates, all your ports open, and if you have some sensitive feature enabled. So to run KubeBench, you have 2 options. The first one is to run the container and to mount all the volume he needs. Or you can install the package directly on the master node and run it. So what we get is something like this. So it's a screenshot of the result. So each line means one role in CIS benchmark. And for each line, you will get a result. So we have 3 kinds of results. The first one is pass. That means that you're compliant with the CIS benchmark. The second is fail, so you're not compliant. And the good thing with KubeBench is it will tell you what command line you have to pass to fix it. And finally, it can be in warning. And the warning means KubeBench cannot predict the result, and you have to run it yourself. And it will also give you the command line to help you. So let's take an example with the warning one. Here, as you can see, the PKI told us that the PKI directory is not owned by root, and it gives us the command line /own on this folder. Okay, so just before do that, I will check this folder, and as I can see, the PKI folder is a symbolic link to the SSL folder, and the owner of the SSL folder is KubeUser, and that is not compliant. So when I apply this command line, now it's good, and next time I will run it, I have to know that I already applied this fix. At the end of the report, you will have a summary of all the remediation you have to do to be compliant with CIS benchmark. And you will see all the number, the ID of the role, and the command line you have to pass. Finally, I will present a fail one. So here, for example, we have the KubeController manager that has an option like bind address that is not set to localhost. And in fact, in this static file, I can see that is actually listening on all the interface, and that is not good, not compliant. So when I put the localhost on it, I just save the file, and as it's a static pod, it will relaunch the pod correctly. And normally, next time we run this change benchmark, the kube bench, it will disappear from the summary. All right, so KubeBench is a great tool for two things. One, you're new in Kubernetes and you want to be sure that you apply the good practices. And also, when you have to audit a cluster that you don't know, it's a good start to know what you're working into. A second tool I want to present is Popeye. Popeye is now not give you the configuration of your cluster, but all the resources you have deployed on your cluster. And it will ensure that you apply the best practices, and it will try to find problem in your configuration file, and you can also customize the roles on Popeye. And I will show you that in a few minutes during this demo. And last tool I want to present this time is Kubehunter, is also made by Aqua Security. It's written in Go as well, as a good community too. And this time, this is not just look at the configuration file. It will do something. So just be aware of that. Before using this kind of tool, you have to prevent the owner of the cluster. If you are in a managed cluster, or even if it's not yours, just prevent it. So this time, it will try to find vulnerabilities and exploit it. It will tell you all the port open, if all the capabilities you have in your pods, finding secrets, and if your impact with the CV. So with Kubehunter, you have three kind of scenarios, and it will simulate what the attacker can do from an external host, from the master node, or directly on the pod. So to run it as an external host, to run it, you have to do the Kubehunter command with the remote option and with the address of the server. On the left, you can see that it will tell you all the service you can find on your cluster, and on the right, all the vulnerability you can find. For example, here we can see that the version endpoint is open, so that means it makes the work easier for the attacker to be aware of if you have CVE. Second option, to run directly on the node. So the Kubehunter with the interface option. And in general, the further you go inside the cluster, the more vulnerability you can find. So you will see this kind of report, and with the same things, almost. And here we can see that he found the endpoint version, endpoint vulnerability about the version. And last option is to run it on a pod. So we define a job with a Kubernetes image and with the option pod. And on the right, we can see the log of this pod. And here we have a catnap row enable. This is used in general to make the man in the middle attack. So if you don't need it, just disable it. And for the rest, like it tells you that you have access to secrets, but maybe it's legit. It's depending on your need. You have to know if it's legit or not. And I will show you Popeye. Popeye, sorry. So to install it, I just using a Crew Manager plugin. Here I can find it. So I already installed for the demo, but it's very easy. You just do the crew install Popeye, and that's it.
Vincent, do you think you could like increase the size of the screen just for the people to read, if possible?
I don't have my mouse.
Oh, okay.
Oh yeah, it's working.
Cool, thank you.
Yeah, better. So to run it, I do the kube command control, Popeye, and I will check what I have on my monitoring namespace. And what we see, we will get a score with a detail of all the resources I'll deploy on my cluster. So it will tell you for each kind of resources the score on it. So here, let's take an example with pods. I deploy an Nginx pod, and it tells me that I don't have probes, liveness probe or readiness probe setting. I can run as a root user on it, etc. So you have all these kind of good practices that Popeye will tell you. And you can also customize those inputs. If you have something that you don't want to see again, you can run Popeye with your config file.
So again, it's a pretty useful tool when we discover a cluster. It happened a lot today that, for example, we are called and they say, yeah, we have set up a couple of years ago a cluster. We start now, because Kubernetes has a couple of years existing, that we have now legacy Kubernetes cluster. And when suddenly we arrive and we don't know how the cluster basically was built, what is running in it, it can be interesting to use this kind of tool before we contract any further step, right? Because most of the time today, it happens that we can have Kubernetes legacies, especially on premise environments, depending on the customer. This is why this kind of tool can be very useful. Thank you, Vincent. So now that we have kind of like checked this first layer with the infrastructure, that we know that basically it seems that the Kubernetes cluster is properly configured, we know what is going on this cluster, what kind of workload do we have, we would like now to build a proper governance, meaning we would like to use the Kubernetes primitives that are like available in Kubernetes to strengthen the security of the Kubernetes cluster, to restrict access, to restrict and isolate, for example, Exchange. And for doing that, we don't have to invent anything specifically, because of course Kubernetes provides already a set of interesting primitives we can rely on. Of course, Kubernetes allows us to implement some authentication for our users, depending on different scheme. Same for the permission. I can restrict user using Kubernetes resources using different strategies. I can control the deployment of my workload using, again, different scheme or strategy that we are going to demo you later. SecurityContext, pod security admission, and AdmissionController for most of them. We can also restrict and share resources in the cluster by using namespaces, quota, limit range, to make sure that when different users or team are using the Kubernetes cluster, we can assign them specific resources. We can also, of course, isolate the network, and Vincent will share that with you later. In the very same way we do that with firewalls and a security group in the context of AWS, for example. And of course, we can audit what is happening on the cluster when we enable a set of API, audit log API, for example, or the audit sync. During this talk, we are going to focus on three main areas. First, we are going to understand how the role-based access control strategy works in the context of Kubernetes, because this is the first step. You will give access to users to your clusters, and of course, you don't want to give them a full access, right? Most of the time, we use Kubernetes in the context of multi-tenant teams, meaning they need to have access only to what is necessary. The second thing we are going to work is we are going to demo you and present the security context and the pod security admission to highlight and control even more what kind of workload under which context they operate in Kubernetes. And finally, we will work on the network policies to demo how we can isolate the network. All right? Let's start with the Airbag strategy, and I'll head over again to Vincent.
Yeah, so before using your Airbag strategy, you have to think what kind of user will interact with your cluster. So in this example, we got some developers like Amory, and Amory, we don't really trust him. So we just want him to deploy pods on a particular namespace. We got some ops, and they can set quota for namespaces or allow traffic between namespaces. And finally, we got some administrator like Olivier, and he's like a god mode. He can create namespaces, create role and users. So we do that in Kubernetes. We first define a role, and on a role you have two parts. You have the resources and all the action you do on these resources. And in Kubernetes, everything is resources, and we access it by REST. So it's building as a REST approach. And when we define this role, after we have to make the link between the user, group of user, or service account to link those to the role. So we do that. We first create a kind role in a specific namespace, like billing, and we will set a set of role like this. And here, as you can see, we can do almost everything on the pods. And for the API group, I will talk about it later. After we define the role, we have to define a role binding to bind my user to this role. So it's namespace resources as well. And here we got two things, the subject to bind the users and the role ref to bind the role we just defined. Now, we're gonna talk about cluster role and why we use cluster role for two main things. The first thing is when you have to manipulate resources that are not namespaced, or if you, for example, have the same role but in different namespace, and you don't want to create in a role for each namespaces. So on the left, we have the cluster role for manipulates namespace, and on the right, we can manipulate pods for every namespace. And how do you bind this cluster role? You have two options. On the left, for the developer, for bind Amory, I want Amory to have access to my pod, but only on one namespace. So you will use a role binding. But for the administrator one, if you have some non-namespace resources, or if you want to access to this role in all the namespace cluster-wide, you will use a cluster role binding. And finally, I just speak about the API group you set on your role. And this is how do you get the info. So KubeControl API resources, and on the second column you have the API version. That's a concatenation between groups and version. So if not group, if there is no group, you can leave it blank. Otherwise, you take on the left part. The good thing about this is also you can see all the native resources, but you can also see your own resources. Like if you apply your own CRD on it, you can do some Airbag on it. And I will show you this in demo. Okay, I'm going to create a namespace for my user armory. So let's apply this one. And after we want to create a certificate for armory. So I will put him in a dev group, like you see in a hole, to create my private key and my CSR. And now I want to apply this on my cluster. So I create a certificate signing request resource, and I will put the CSR of Armory inside the request. And I will encode it in 64 base. So that is what we got, all right. So now we're going to apply this resource. And for the moment, it's in pending. So that's normal. We have to approve the CSR. So let's approve by using the kubectl certificate approve command. And now it's gone. No, it's gone. It's done. Sorry. So here we can see that it's approved. And we can get the certificate if you want. So that's been signed by Kubernetes. OK. Now I want to give to Amory the kubeconfig file he needs to connect to my cluster. So you have to define 3 parts. The first one is to set the cluster we want him to connect. And we will give him the authority certification. The second one is the credential of Armory with his private key. And finally, the context to bind my user to my cluster. And I will tell him that he will use the billing namespace by default. Yeah, like this. All right. So we have this kind of file, and we got our 3 parts, the cluster part, the context part, and the user part. So now we're going to try to connect with this file. Sorry. So yeah, it cannot access to my pod. It still cannot access to my services, and it cannot run any pods. That's normal. That's just because we do not define some role for him. So now let's apply a role in the namespace billing. And I will take the API resource. So like it's v1, so I mean blank for the API group. And I want him to just get and list pods on the billing namespace. So we define this like this with this kind of rule to get and list on pod inside the namespace billing. After we do that, we have to define a role binding. So I will put on the subject a kind group to bind all the users that are in the dev group inside the namespace billing. And I will bind them to the role I just created. I apply this. All right. So let's try again. So now he can access to the pod. There is no pod actually now in the cluster, but he can access to it. He still cannot get services, and he still cannot run pod. OK, now I want to update this one, this role, and I want him to almost do everything with his pod inside the namespace billing and create his own services. So we can see that there is 2 rules now, one for the pods and one for the services, because I use different verbs. So let's update this one and try again. So now we can run some pod we can get, and we can run services. We still can get delete pod because we put the all option on the pod. And I don't know what's the problem. All right. And the last one, the last thing I want to show you, that he still cannot get services because we allow him to just create services. All right. Now I'm gonna show you. Oh, yeah, I'm gonna clean all the stuff. I'm gonna show you how do you do that with service account and go a little bit deeper. So yeah, now let's create a service account in the backend namespace named backend app. So we got the service account created, and we can see all the API version using the API resource command. And so the first thing I want to allow for this service account is to get and list on pod services and deployments. So you can see the two different syntax I use here to define this. Everything is on the space backend. I can get and list on pod services. Oh, just see that I forgot the deployment. Oh no, it's here. Sorry. And I put the second rule for get and list deployments. And why I use two rules? It's because it's not on the same group. Okay. To link this role to my service account, I use this time a role binding, and here you can see that the subject had changed, and here it's a service account. Okay. To try this, I create a pod with a Airbag Access Matrix Crew plugin on it, and I will log on it to see what kind of access I have. So as you can see, you can get and list on pod services and deployments, but we cannot do anything on replica set, daemon set, or secrets, and even more on namespaces. Right. Now I want to update this service account for allowing doing more things. Just please don't do that in production. That's just for the demo. Allowing him to manipulate namespace with a full access. So for this, I will create a cluster role named namespace creator CR, and I will bind this one with a cluster role binding this time, not a role binding. And if we want to go further, I will now this time create a cluster role specifically for reading secrets, and I use this cluster role on all the namespace I have. So, and for the backend app service account, I just want him to allow to get secrets, but only on the backend namespace. So to do that, I use this time a role binding and not a cluster role binding. That's the difference. So let's try again. I run my pod again, and now it's running. All right. And here, as you can see, it still can have access to get and list on pod services and deployments and secrets now, and it can have access to. It can manipulate namespace. So just don't do that in production, but that's to show you everything you can do. All right, that's the end of this demo.
So what we have seen with this demo, first thing is like, it's pretty time-consuming, not so sexy, and we can understand why we have now some solution like OpenShift, Rancher that help us to manage those kind of resources, and as well why it's very important to connect those roles directly to IAM, for example, or any external permission engine that you could have at your organization level, because of course we don't want to do that manually on a daily basis. However, Airbag come with some kind of like cool features. But we can't cover all the cases. For example, with Airbag, it's just a Boolean, meaning either you have access to resource, either you don't have access to resource. And especially in Kubernetes, it's not always great, right? What if we take an example? I would like to give my users the ability to create only services that are cluster IP. But there is no way I would like to allow him to create not port services. You can't do that with Airbag because you can just allow or disallow the access of this resource, not the subtype of this resource. Same is happening if you like to restrict the context of the creation of the manipulation of the resources. What's happening if I can create some resources only according to some conditions that are dynamically assessed on the process time. For example, I can create an ingress, but this ingress has to be named after a certain format or name. With Airbag, it's just that you have access or you don't have. There is no way you can dynamically reject, for example, the resource. Okay? So now we are going to move to how we can control deployments. And we are going back to the basic very quickly. When we run container on Kubernetes, like in every systems, we have the ability to run it as a root, non-roots, privilege, unprivileged. And of course, what we would like to do is to run container as non-roots because they provide limited access to the container. And we would like to run them as unprivileged as well. Right? Seems pretty basic. How we can do that? In Kubernetes, we have the ability to specify a set of keys to restrict the access control. For example, we can define which users will execute the container. This is possible. We don't have to do any tricky things. I can just pass that as a parameter of my deployment. Same is happening. I can restrict, for example, any privilege escalation, which is kind of interesting when we want to make sure that the workload that we run are executed in a safe context. We also have the ability to restrict the container isolation. For example, I would like to disallow any container to be able, for example, to connect to the hosts. I don't want any container to connect directly to the host path, for example, to manipulate the file system, or I want to deny any container to manipulate the network stack. This is what we want to do. Again, there are some keys allowing us to do that. We can also restrict the Linux capabilities, meaning that when a container will try to do some specific call system, we will be able to deny and drop those capabilities. And finally, when it's set up in our Kubernetes cluster and infrastructure, I can label my workload to use SecurityContext, AppArmor, or Secomp. The way we can do that, we can use SecurityContext. Okay, so here I am in a deployment file. Okay, it's a very standard deployment, and I have now a spec which is called SecurityContext, and this SecurityContext allows me to specify the key I want. I will be able to run a specific users and a specific group. Same is happening with the SecurityContext that I can define both at the pod level, but also at the container level. Because of course, if you have, for example, some advanced pattern, for example, you have an init container, or you have like a sidecar container, maybe you would like to restrict those rules depending on which container you run. All right? So this is great, but it's not perfect. Why? SecurityContexts work only during the runtime. It means that, for example, when I defined a security context, first I need to trust that the developer that has been implementing the YAML file will actually use the value I tell him to do. The second thing is that its work on the runtime. It means that when, for example, I will apply and deploy my container, this container will be actually like deployed, meaning the pod will be created. But if the container does not comply with the rules, it will crash. So it means that if I inspect my namespaces, I will see my pod because it has been accepted, but the container will crash, which is not awesome. A better way to do that is to use pod security admission. Okay? For those of you who have been using like Kubernetes for a couple of years, before we had this concept called Pod Security Policy, PSP, but it has been deprecated since the 1.21, and starting now today, because today we are in the 1.25, it's completely removed, so there is no way you can use that anymore. This pod security policy plus pod security admission works a little bit differently. They work at the creation time of the resource. It means that when I will create a pod, in case this pod violates the policy, he will just not be created, meaning the container will not start, which is much better. Okay? So the pod security policy has been deprecated because it was kind of tricky to manipulate. We had to create an Airbag rule, making sure that the pod that was executing this security policy was actually bind to these users. So now we have the pod security admission, and I will deep dive a little bit regarding how it works, so you can have a better understanding of how is it working and how is it different from the pod security policy. So in pod security admission, we have different modes. We configure different modes depending on what behavior we want to achieve. The first mode is enforce. It means that basically, whenever the pod does not comply with the policy, it will not just run. It will be completely like impossible to run it. So it's pretty a strict application of the desired policy. The second mode we can use is audits, meaning if the pod does not comply with the policy defined, he will still run. However, in the audit log, we will have an entry explaining that, hey, we have accepted to deploy the pods, but is not complying with the policy we defined. So probably you have to take a look. And we also have the warning, which will do the same, but directly as a warning message just after we deploy the resource. Okay, so if I apply my resources, the pod will be created, and as a warning, Kubernetes will say, hey, please, you should take a look at that because probably you need to fix that. Now we have levels, okay? I have defined a mode, how much I want to apply the rules, and now we have levels. Levels basically are the policy you will use. You have 3 different levels: privilege, baseline, restricted. In privilege, nothing new. Basically, it's like if you were doing nothing, you don't apply anything. At baseline level, you start to restrict pretty interesting cases. You, for example, deny privilege escalation. You reduce the connection between the container and the hosts by adding this kind of like distance, which is cool. But again, it's not fully restricted. And the most advanced level will be restricted, in which you will add on top of the baseline 2 extra things. Mostly, it will be not possible to run as a root. And finally, we will drop some extra Linux capabilities. How do we define this pod security admission? It works using labels. And for example, we will put these labels directly on the namespace. Here, I have defined the mode as and the level as baseline. Okay, it means that if I come back to the previous stage, I start to have some isolation. I start to create an environment in which the container that should be executed should comply with a set of best practices. Okay, and enforce, meaning that the container will not be able to execute if it does not comply with the baseline. Okay? Enforced, remember, is the mode, and baseline is the level. Okay? And of course, I can define more mode and level. So for example, I have defined audit restricted, okay, on the next line, and also warning restricted. Why I want to do that? For example, today you would like to apply the baseline, but you know that maybe in 1 to 3 months, restricted is going to be the case. Then you want to prevent your users, you want to warn them that this is going to come. And so, yes, today it works, but maybe tomorrow this is not going to work. So this kind of multiple definition can help to conduct the change in your organization by splitting down the effort to migrate to a more restricted mode. Okay? A question you could ask is, what is it with the version? We have enforced version here. We could ask ourselves, but why do we need a version? What is it about? Because you can only use levels that are predefined by Kubernetes in a version, it can be interesting to specify the version. Why? Because tomorrow, maybe the baseline will be different. If you upgrade your Kubernetes version to 1.25, maybe it's possible that the baseline will be more restricted than the baseline of the previous version. And you don't want to have some issue when you upgrade your Kubernetes cluster, and suddenly nobody is able to use it. For doing that, you have the ability to assign a specific value that ensure your retrocompatibility, meaning if you upgrade, this is still the same rule that will be applied. Again, it's great, but it's not awesome because if I need to define that in every namespaces, if I have 10,000 namespaces, not so great. What we can do is define that directly at the cluster scope level. It means that I will define the pod security admission that will be applied for every namespaces. Here again, I will define, for example, my pod security configuration with enforce privilege. If you remember, it means that basically it will do nothing per default. But I will start to to warn maybe with enforce and audit. Okay, in this case, it's pretty like open bar because we allow every level on every mode. What is interesting as well with this file, we can set some exceptions. Okay, meaning that, for example, if I have specific namespaces that should work as privilege, for example, kube system, then I can define that here, because otherwise, again, this is going to be messy. Or for specific users as well, or if you use specific runtime. Runtime class is, for example, I have one node that is running not containerd or not cryo, but maybe you are using gvisor, and on this specific node, you already have a pretty interesting isolation. Maybe you don't want to add and restrict more. So it can be interesting if you have Kubernetes cluster that have different runtime class to exclude the application of the pod security to those runtime classes. Okay? And now we are going to run a demo, and Vincent will help me to run this demo. We are going to start with a security context that is going to enforce a rule. And for doing that, we will deploy, for example, an Nginx web server, something pretty standard. We are all doing that every day for a lot of people, and it's kind of interesting because when you pull the default Nginx image, the official one, Nginx run as a root, and of course, this is not awesome. So here, we have defined the specific users, which is not root, who will run the Nginx, and we disallow as well the ability to run a privilege escalation. Then now what we are going to do very logically is that we would like to deploy these resources. Like I mentioned, because the security context work at the container runtime, the pod is created. We can see the pod is here because we do kubectl get pod, and the pod is actually created. However, the container is crashing because it lacks the required resources to actually run. Okay? So if you remember, we are working at the container level time, so it means that the container try to run but crash, and the pod is still created and there. We can, of course, enter the logs, and we can see, hey, because I don't have the required users, I don't have the permission, and blah, blah, it's done. Okay? Now what we would like to do is to try that, but using the pod security admission, okay? So the idea would be that instead of allowing users to create the pod that will ultimately crash, we will just restrict directly the creation of these resources because it doesn't make any sense. So we have created these namespaces, we have defined the rule, enforce, restrict it. This time we try to run again the Nginx, and this time we clearly have a message because we are working at the admission time, saying that, hey, there is no way you can create this pod. This pod does run as a root. We don't allow that in restricted mode. Sorry, you can't create this pod, and then it's a much better approach. Okay? So as you can see, very easy to use, very easy to deploy, so it's kind of interesting. And now we are going to go back to the presentation. So one interesting thing as well is that we are still in the Kubernetes cluster, meaning that if tomorrow you go back to your company, you say to your boss and your team, hey, I've seen a great things, we should do that. Yes, but we have a production cluster. We are running a couple of workloads. How can we define the risk and how can we organize the migration? The first thing we can do is reuse the basic. We can use the dry run command to actually start to identify which resources will be impacted by this pod security admission, which is great. It means that we can plan how much effort do we want to spend after we have applied this rule for the rest of the devs team. Okay? So this is pretty interesting. Of course, just saying you can't run non-root, you can't run root images is not enough. At some point, we need also to help our people to build non-root images. And can I show you, we had a couple of interesting discussions with developers saying, yeah, I need a root, okay, tell me what you need to do. And there is absolutely no way you need to have a root if you don't do one of the 4 steps, okay? For example, if your container don't do any change of the hosts, basically, if your container does not try to access volume, if you don't need to install dependency during the runtime of the container, if you don't need to use privileged ports, then there is no way you need a root users. You can do differently. And we can help you for doing that, okay? So at some point later in the past, maybe there was some limitation, but today for all these problems, all these limitations, we have a solution. And then there is no more excuses to run roots for some workloads. However, so what we can do, the first thing is that we need to learn how to do that, and we need to help our devs doing that. And here I would like to highlight a great work that has been done by Betnami, and they have produced a ton of documentation about how we can build non-root images. This is very interesting, and since they are doing this great job, they also have published a very large amount of images from popular distributions and tools that we can use that are running as non-roots. And this is great because they are regularly updated, and we can just take these images, run it, and they run per default as non-root. And this is great, okay? Very popular. I'm sure that you are all using already these solutions, so you can take a look. It's already done, and if you want to do it yourself, you can just take a look how they did it and try to reproduce that. So running as non-root is great, but if we want to go a little bit further, we can also use distress images. Distress images, it's a project from Google, and basically it's an image in which you only have your runtime interpreter. It means that they have get rid of everything that is not the interpreter. If you have a PHP images, there is only the PHP process. There is no shell inside. No cat, no ls, no ps, no nothing. Same is happening with Java, same is happening with Golang. So you only have the proper languages runtime, and the rest is completely does not exist. This is quite of interesting because it completely reduces the surface attack. Because basically you just have your interpreter, so there is no way we can use something that is not required, right? It enforces the isolation, of course, and it also protects secrets because you can't exec in the container, you can't travel in the container, you can't open anything in the container. So it's a pretty advanced cases, but it might worth to take a look sometimes if we want to reach this kind of isolation level. We are going to finish with this last part by the network isolation. And I will hand over again to Vincent, who will share about network policies.
So yeah, by default, in Kubernetes, all the network is open. It's open bar. You can do everything you want. So this is great, but not for production. And what we want to do is kind of isolate each namespace between them or pods between them. And how we do that, it's by applying network policy. So by default, the best practice is to deny everything and to open only what is legit. So in this example, on this network policy, we deny all the traffic on the namespace billing. So any pod in every namespace cannot communicate to a pod in the billing namespace. They can talk, but they can no one can talk to me. So that's good, but if I want my front to communicate with my backend app on the same namespace, I have to add another network policy. So now it's additive, so everything is closed, and if I want to open a door, I have to explicitly do it. So here what I allow, it's to define a network policy on the billing namespace to allow a front pod. So the pod who match the label role front inside the billing namespace can communicate with the pod who has the role back. And this is great, but if you have so many pods inside your namespace, maybe you don't want to do this for each pod. So you can do it for namespaces, for example. That's not the best practice, but you can allow every traffic inside your namespace, but you disallow every ingress traffic outside the namespace. So if, for example, you can allow the catalog namespace to communicate with my role backend in the billing namespace. And we are doing that by using another network policy. Here's the difference on the ingress. You can see that the from is using a namespace selector. You can use, so that means all the pods who are in the catalog namespace will have access to my pod on the billing namespace. And I will show you this in demo. So first of all, I will create my two namespace and with my pod on it. So yeah, looks running. All right. Now I want to try to communicate from inside the same namespace from the front to the back. So it's okay, it's normal because I do not apply anything. So let's deny everything by applying this network policy inside the billing namespace. And we define in the spec section on the pod selector, all pods in the namespace cannot be accessed to by anyone. And let's try again. So here I launch a command, but it's in timeout. So we effectively block the traffic. And let's see if we can communicate to someone else. Yes. So here I communicate from the app back inside the billing namespace to another namespace. And this is still allowed because we only restricts the ingress traffic, not the egress traffic. But the opposite, communicate from the app back in the other namespace, it's not possible. Right. So it's timeout again. Now, I want to update this network policy to allow all the pod in one namespace to my namespace directly. So using the pod selector, so that means all the pods that match the rollback label will be concerned by this network policy. And I allow all the ingress traffic, so all the ingress traffic for all those pods who has the role front label. And now, now, as you can see, the front pod inside the billing namespace can communicate to the back in the billing namespace. That's clear. Just before, we cannot communicate inside the same namespace. Now we can. Oh yeah. So now let's apply a deny policy from all other namespace in my billing namespace. So we're doing that by applying this network policy on the billing namespace, and here we can deny all the traffic inside my billing namespace from outside to my billing namespace. So let's update this one and let's try again. So inside my namespace, so I clear everything. I just put this one inside my namespace. I can communicate, okay, and I disallow from outside my billing namespace to communicate with my AppBack pod. So here it's in timeout. And if I check if I can communicate outside the cluster, we still can do that because we do not do egress traffic, egress network policy. So if I want to do that, it can be useful when it's more important to block your indoor than the egress traffic, but sometimes you can need it. And you do that by using another network policy. But the thing is, in the policy type, you put the egress, and here all the traffic from the back pod will be disallowed. So let's apply this, and if I try to curl from the back pod inside the billing namespace, I can't communicate with outside my cluster. And if I try this time to communicate from my front pod inside my billing namespace, I still can do it because I select only the AppBack pod. All right. So to do that, to apply network policy, you need a CNI, and you have a lot of CNI available. I use a lot Calico, but you can use Cilium and Kubernetes. Each of them come with some more functionality, and for example, here we just saw that there is a L3 deny traffic, so it's bound by address, IP address. But if we want something further, like we want to deny all the GET requests or all the POST requests, some of those CNI can offer you this kind of possibilities. And you have to know, depending on your need, what's the better for you. And yeah. I will let you the talk.
So if we summarize what we have seen until now, we have used some tool to audit the technical configuration, so we are pretty confident about the structure of the Kubernetes cluster. Then we move to use primitives offered natively by Kubernetes to restrict accesses, to set up permissions, to control the way we deploy things in the cluster. And with this last part, we have now restricted the network communications inside the cluster. Because Vincent mentioned, everything is open per default, meaning that if you have 10 teams working on the same cluster, if you don't do anything per default, they are able to talk to each other, which is not awesome. Okay? We have seen some limitation. Okay? With Airbag, we mostly have like true-false evaluation, which is good but not great. We have seen as well that it's pretty like time-consuming to administrate, operate, and manage all this role, and that it can be interesting maybe to leverage some external tool for that. And we have seen now that with the network policy, per default, we already have a pretty interesting way to finally control how the pods are communicating to each other. In a very close way, we are doing that when we are working on AWS with security groups. I can label some pods, they won't be able to communicate to each other, and I don't have to use any external tool, which is great. In the next part of the session, we are going to talk about AdmissionController. Marion is going to present you what is an AdmissionController in Kubernetes. We're going to focus on that, especially with Opa. We will talk as well about Falco, how we can monitor activities running in the cluster. And we will end up with image scanning to make sure that we deploy safe workload in the cluster. I would suggest that we do a short break, allowing us to get some rest, to think, allowing you to move, take a coffee, and maybe we can meet in 20 minutes. Okay? If we can meet in 20 minutes, I don't know what time is it. Okay, let's say, yeah, at 3 p.m. we start again, and if you have any question, feel free to come to us. Thank you very much. All right, welcome back everybody again for the second part. I hope you enjoyed coffee, drinks, and now we're going to move to the AdmissionController. Marion will explain what is AdmissionController and how we can leverage this interesting feature to expand the way we control the deployment in Kubernetes. Should we, Marion?
Sure, let's get started. So in the first part, what you've seen is that you can use Kubernetes native resources to do a first bunch of things on your cluster to enable security. What I propose now is to use AdmissionController to go further. And we're going to start from the very beginning and check what's happening when you're making a request in your cluster. So if you're doing a kubectl create in your cluster, what's happening is that you're sending a request to your API server. This request is going to go through the usual step we already saw with Vincent and Ludovic of authentication, authorization, and then something amazing happens. The AdmissionController are called. So you may not be familiar with the term, but you already know what it does, actually. You have two types of AdmissionController. You have the mutating AdmissionController and the validating AdmissionController. For instance, if you boot your Kubernetes cluster using an image pool policy to always, when your request, the deployment of a pod, for instance, will reach the mutating AdmissionController, no matter what you put in your YAML file, your pool policy will be overwritten with the value you put at the start of your cluster. So the image pool policy will be always, no matter what you put in your YAML. Okay? That's an example of the mutating AdmissionController. Another example you all experienced already is the example of the namespace exist validating AdmissionController. You will be able to deploy your pod in your Kubernetes cluster only if the namespace in which you want to deploy it already exists. Otherwise, Kubernetes is going to deny the deployment. Okay, so you have a bunch of admission controller like that, and what's very nice with the mutating admission controller and the validating admission controller is that there are webhooks attached to them, and you can plug either your own code or a third-party solution to those webhooks. Okay, if you want to plug your own code to them, then you will have to write it, of course. And then you will have to maintain it a long time, so that's a little bit complex, depending on how specific you want to be and how you want to own this piece of code. The other solution is to use third-party solutions that are made for that. For instance, OpenPolicy agents that will natively plug on this webhook. Okay, so OpenPolicy agent is in fact a policy engine. It will allow you to make fine-grained governance on your Kubernetes cluster. It has been created a few years ago now by Styra, and it's hosted by the CNCF till 2018, so that's quite old. That's very well supported by the community because it has been using in production for a long time now by plenty of big users. And in the end, what Opa lets you do is to write policy as code so that you can have the finest grained governance on your cluster. I say on your Kubernetes cluster, but you don't have to use it with that. OpenPolicy agent is agnostic, in fact. So if you have on one side a Kubernetes cluster and another side a VM with your application deployed on it, that's not a problem. You can apply the very same policy on both environments because OpenPolicy agent is agnostic to the infrastructure. Although it's agnostic, it's very well integrated with Kubernetes, but it's still using a specific language, which is Rego. You can check on the internet. You have plenty of examples. You have plenty of built-in function you can use to help you upskill with the Rego. Okay, so maybe now you are convinced and you want to deploy Opa in your Kubernetes cluster. So what is it going to do in the end? Well, it's going to deploy a pod with inside 2 containers. You have the Opa core and the kube management. What the Opa core do is that he's going to take the decision when it's called by the mutating webhook or the validating webhook. And how is it going to take this decision? Because the kube management is in charge of controlling all the time what's happening in the cluster and checking all the new policies you have deployed in the cluster. And each time there is an update, a creation, or a modification of a policy, the kube management will update the Opa core. Your governance policy within the cluster are in the form of a config map. So you probably know that in the config map, you can put a piece of code of any language you want. Well, this piece of code, you're going to write it in Rego, and that's your governance policy rule. Okay, so this is what Rego looks like. Here you have 2 examples of types of governance policy you can implement. So you have input-based policies and context-based policies. Okay, there are 2 simple examples. In the first one, I will deny the deployment of any pod with an image tagged latest or not tagged, because that might not be a very good practice in a Kubernetes cluster. So here the Rego sample of code, say you take the input. The input is your admission review. You know, when you are doing the request to your Kubernetes cluster, it's your object is wrapped in an admission review. So you take this input, you go through the request, through the object, and you reach the specification of your like YAML file. Okay. Inside, I'm going to loop on all the containers. That's what the underscore stands for. That's a loop, an iteration over all containers. And for each of them, I'm going to get the image. And then I'm going to check with the built-in function ends with that the image does not end with latest. And if it does, I will display the error message. Latest images are forbidden. So you can see that's quite easy to read, a little more tricky to write, but you'll have to experience it to know that. Okay, the second type of policy you can have is the context-based policies. It will take the input as well, but it will compare it to what's already existing within your cluster. So for instance, if I want to avoid ingress conflicts, I don't want anyone to create an ingress with a host that is already existing in the cluster, in another ingress. I'm going to take my input object, loop over every rules, and take the host for each of them. And then I'm going to look in my Kubernetes cluster, and that's what's in bold on the slide. I'm going to take all the data of my Kubernetes cluster. Among those data, I'm going to take all the ingresses over every namespace, whatever their name are. And for each of them, loop over all the rules and take all the hosts. For each of my input hosts, I'm going to check what's already existing. And if I find the same value, then I will display the error message of host conflict. I will show you this example in action, as well as others in the demo. There are a bunch of governance policy you can implement like that. For instance, you can enforce the usage of your corporate registry. Like you don't want anyone to pull images from Docker Hub, for instance, and you want them to pull images from your own registry. Okay. You can enforce namespace labeling. That's a mutating policy. You can add a label each time someone is creating a new namespace in the cluster, depending on their identity or whatever you want. You can enforce the pull always policies for images. Okay, there are a bunch of examples like that. Okay, so you implemented your first config map, and now you know how to write Rego policies. So you're writing policy as code. That's great. Probably you would like now to treat really Rego policy as code, which means to create pipelines according to that. For instance, a unit test pipeline. Because what is going to happen when you're going to create a new policy in your cluster? What is going to happen when you're going to modify a policy in your cluster? Well, probably you want to unit test it to be sure that you're breaking nothing. Another thing you can do is that when your developer teams is writing new YAML file to be deployed in the cluster, and they are submitting a pull request to you, you don't want to wait to accept the pull request and to wait until the application of the YAML file in the cluster to have the message from Opa, like, hey, no, you're not compliant with that, you're not going to deploy that. Because then you will have to tell your developer, okay, you have to change that, the developer will change it, submit a pull request again, and so on. So what you might want to do is to create a compliance pipeline, which would be a pipeline comparing in advance before trying to deploy actually in the cluster, checking that your YAML file are compliant with the policies you're using. Okay, so there are two ways to do that. Either you put all your Rego policies in the same repository as your YAML file, and you are checking your YAML file against all those policies. Or you're going to use your runner if you're good using GitLab CI, or your slave if you're using Jenkins, and you're going to ask him to get at runtime the already existing policy in the cluster. So if you do that, you don't have any extra folder of policy to maintain, because it's going to take dynamically, it's going to fetch all the existing policies. And why is it going to do that? Because then you need those policies to evaluate your YAML file against the policies. All right? So this evaluation, I will show you in just a minute. You're going to do that with kubeval and conftest, which are two very nice tools. Here I'm using a certain version of conftest, but Opa has his own, so you can use that too. Okay, so this is what your GitLab CI file could look like. You can order it for the compliance pipeline. You can order it in 3 stages. The first stage will use kubeval just to check if your YAML files are well written. Because if they are not, then there is no need to launch the rest of the pipeline, right? Okay, so you get all your YAML file, and you put that in a particular directory of your GitLab runner. Okay. Second step, you will ask your GitLab runner to curl Opa service so that Opa can send back all the current policy existing in the cluster. You're going to get the output. You're going to format it a little bit and create rego file for each of the policies. All those files, you're going to put them in a specific folder. And in the third stage, what you're going to do is that you're going to compare the first folder, the one with the YAML you're trying to deploy, with the second folder containing all your policies. For that, you're using the conftest image, the conftest binary. And you're checking within the compliance pipeline if your YAML files are compliant with the governance policy existing in the cluster. And what you have on the left side is the output of the pipeline. Right away, you can check the logs and see what could be modified so that there is no problem when you are actually trying to deploy in production. Okay, so this is still the pull request stage. You launch the pipeline, and then you realize there is no need to check on this pull. Well, the developer realized there is no need to check on this pull request because it's going to fail anyway at the end. So he can right away make the modification useful to create a nice pull request that's going to work in the end. All right? Okay, if that's clear for you, let's go back a little bit to the unit test pipeline, which is important as well, because when you would like to create a new config map or modify an existing one, you don't want it to create any conflicts with the other config maps in the cluster, the other policies in the cluster. So what you can use to do that is using a debug version of Opa image, the one you want, like the 0.45 is the last one, for instance. And inside, you can use the command test. And you're going to test all your rego file, which are your governance policy, against all your unit tests, which are in the rego format too. The unit test, you should write them beforehand. So I will show you during the demo what it looks like. That's a bit tricky to write, but you have, on the top of the slide, you have the playground, which is offered by Opa to train your policy and to train your unit tests and to learn a little bit how it works. You also have plenty of examples on the internet, so you don't have to invent the wheel again. Just use what's already existing as a first start. Okay, so now you have Opa deployed, you understand how it works. Maybe you've put in action those 2 pipelines, and that could be great. Be aware that every time from now that someone is doing a kubectl create, a kubectl apply in your cluster, is going to go through Opa, which means Opa can very soon be the bottleneck of your cluster if you do not pay attention to it. So one of the good practice would be maybe to monitor Opa as a an infrastructure component, because it is actually. If Opa is slow, all your cluster is going to be slow. So maybe we want to check on that. You probably have already Prometheus and Grafana as a monitoring stack implemented in your cluster. So what you can do is just configure Prometheus to get the metrics that are natively exposed by Opa. Those metrics, you can use them to create a dashboard. For instance, with the red pattern, request, error, duration. And you can monitor that way, for instance, the number of instances of Opa, especially if you are using horizontal pod auto-scaling. You want to see how Opa is scaling depending on the number of requests or the duration. You're going to check the number of decisions taken by Opa, among which the number of errors. You're going to check the duration of each of those decisions to monitor the throughput of Opa. And if you want to go further, you can even get the logs, actually, to have a little bit more context around that. So you can deploy an Elasticsearch and a Kibana and do dashboard with the logs and see what's happening inside Opa. OK, an example of dashboard for those metrics is this one. So here you can see I'm monitoring all what I told you, the number of instances and so on. But the most important part is the heat map you see in the bottom, the blue one. That's the duration of Opa with the time. What's important here is that it will allow you to check if you're meeting the requirements you or someone else set for your cluster. If your client asks you to make a cluster which will be more responsive or has a very short response time, then this is what you want to check. And if Opa is responding in a too long time, in a too long delay, then maybe you want to scale Opa so that it can go faster. OK?
Just to be precise on that, this is because now every single decision will go through Opa, meaning every time we create a resource, we edit a resource, we delete a resource in Kubernetes, it means that nowadays everything is going to be processed by Opa. Meaning that if I have the wrong setup, I can just slow down completely the entire Kubernetes cluster, which of course is something we don't want. And this is why we need to have a proper setup to make sure that even with this extra layer of control, I am not giving a terrible experience to my users. This is really why this is important for you to understand. This is not just an extra. This is something we truly want to control and measure. Let's go back to the demo.
Yes, let's go.
You can zoom in. Yeah.
Maybe more. OK, is that OK for those in the back? Yeah? OK, great. OK, so I installed on my laptop a simple Minikube cluster just to show you the demo. On this cluster, of course, I already installed Opa. Opa is installed in the Opa namespace. It's not very original, but that's how it works. And I also installed a bunch of config maps. So we're going to check some of them during the demo, and some other we don't. For instance, well, the first one is the ability to deploy ingress depending on namespace. I will show you that. The third one is the ability to use only a specific whitelist of registry. I'll show you that too. We can see again the deny image latest, which won't allow you to deploy a pod with the latest image, and the ingress conflicts, that the two examples I showed you during the slide. OK, so let's go. although I implemented Opa on my cluster, well, I'm still going to try to enforce and to deploy things that are not compliant. So let's start with the input-based policy. I want to deploy a pod based on an untagged image. So for that, I'm just trying to run an nginx from docker.io without specifying the version, which means the latest image for nginx is going to be pulled. And I got what I expect, actually. Opa is reacting right away, denying the request, and telling me, in fact, the error message I implemented in my governance policy, which is latest images are forbidden. To focus on this message, and we'll see that a little bit later, that's nice if you're very clear on this message about the error, because that's what your developers teams will have. So if they have to modify something, they should know what they have to modify, okay? Okay, then let's try some context-based policies. All what I'm doing here, I'm doing it in a demo namespace, which is named demo Opa, so you can see the YAML file here. What I did is that I had an annotation in my namespace saying registry whitelist is docker.io. So that's a list, but I have only one element inside, whatever. And I implemented a policy on my cluster saying my registry for the namespace demo Opa should be in this list, otherwise deny the request. Which means if I'm trying to use an nginx image from quay.io in the namespace demo Opa, I will have a deny from Opa saying the registry quay.io is invalid for demo Opa namespace. Moreover, I added some details on the error message to tell the developer what he should use instead. So one of the registry whitelists, in this example, docker.io. Okay, let's try something else. I'm going to try to deploy an ingress, but I also put another rule in my cluster saying that every host of every ingress should end with the name of the namespace .devox.com. So in this case, I'm trying to deploy a namespace with the host foo.devox.com in the namespace demo Opa. It's not going to work, because instead I should use whatever I want, .demoopa.devox.com. All right, let's try that, just to be sure it's working. So if I deploy foo.demoopa.devox.com as an ingress, it's working. So I have the ingress created in my namespace demo Opa. That's great. So now let's try to deploy the very same ingress, but in another namespace, for instance, the default namespace. Well, I told you already I have another rule for that, avoiding conflicting ingress. So if I try to do that, OPA will deny it, saying my ingress is in conflict with the ingress inside the namespace demo Opa, name ing. Okay, so that's how it works. You can make very simple governance policy on your cluster, like denying the latest images, or you can enter in much more complex governance policy using what's already existing inside the cluster. Okay, if that's clear for you, now let's check a little bit on how you can write a Rego governance policy and the associated unit tests. So I take the same example as from the beginning, the OPA deny image latest. What I do there is that I'm going to allow every pod except if it enters in one of the two deny blocks. The two deny blocks are almost the same. In each of them, I'm checking the type of operation. So I want to apply my policy on creation and updates. I'm going to check the kind of the resource I'm trying to deploy and apply my rule only if it's a pod. Then I'm going to go through all containers and each time take the image, check if it ends with latest or if it's not tagged, and in case it's not, display the error message. Okay. Now let's check on the associated unit test. There are two parts in this test. The first part is the data sets you're going to create to test the second part, which are the unit tests. Okay, so the data set is basically a function with an argument as an entry. So my function is named deployed with version image, and the argument is the name of the image. In this function, I don't have to put all the YAML file. I only put the fields that interest me to check my policies. All right. So I use the operation type, for instance, a create operation. I use the kind to say it's a pod. I use the namespace to say I deploy in the namespace called namespace. Okay. And then I create my object, and inside my object, I specify in my container my image. And this image, img, is a variable I can change in my unit test just below. Okay, so for this policy, I'm going to make 3 unit tests. One that's check for a valid image, for instance, busybox stable. One that's going to check for latest image, busybox latest. And one that's going to check for an untagged image, busybox, without specifying any version. So in the first case, what I want is to have no denial. So I'm going to count all the denial and check if it's 0. In the second test, I want to have 1 denial. Okay, I didn't really specify it. What I specified is that I want to have the error message, latest images are forbidden. If you want to set 2 different error messages, if it's tagged as latest or untagged, then you can, but you will have to implement that in your unit test. All right. So if I try to run that, I can use the binary Opa I already downloaded on my laptop with the command test and tell him to check my Rego governance policy against my unit test. And yeah, you can see it's passing. Great. I can also do that on my old file. And then Opa is going to take, on my old folder, sorry. And then Opa is going to take the whole policies folder with the whole unit tests folder and compare them. So each of my dataset should be compliant with every single policy, every single unit test I implemented. And if I do that, luckily, it's passing also. So I have 25 unit tests against 25 that are passing. Okay, this is exactly what you can put in your unit test pipeline. Okay, if that's okay for you, let's go back to the slides.
Maybe we can just summarize again. The purpose, of course, if the unit test is that starting from now, we programmatically pilot the Kubernetes cluster, meaning we have a set of piece of code that change the regular way Kubernetes is operating. And of course, because of that, we want to make sure that in case we change something, we are aware of that. We are just like coming back to more like software engineering principle. This is why we are doing that. The second thing that is interesting, you may have noticed that we are running a lot of labels that we set up directly on namespaces. It means that starting from now, we can set different labels on namespaces to as well implement very customized behavior. Here, for example, we can set up whitelist for registry, whitelist for ingress. We could define, for example, extra behavior if we want to deploy the resources somewhere else, just using these labels, because the label will help us to materialize the behavior we want in these namespaces. Starting with OPA, you can then programmatically control the way you would like to customize deployments. And this is why we need the unit tests.
Yes. So now what's going to happen when you're deploying OPA? Well, that's the limitation I encountered when I tried to deploy it. So what I first did is that I tried to deploy OPA in my cluster using the Helm chart, which is great, but it's somehow deprecated now. I don't know if it's really official. What I encounter is that the Helm chart is pre-configured with plenty of example. And yeah, basically I could never overcome this example to make it work with my own configuration. So I would not advise you to do that. Have a look at it and maybe just deploy OPA the native way using basic YAML files. What you can do too, if you want to use OPA within a Kubernetes cluster and you don't need OPA in another environment, is to use Opa Gatekeeper. Opa Gatekeeper is the Kubernetes version of OPA. The thing with Opa Gatekeeper is that the mutating policy, for instance, the fact that you want to enforce label on certain namespace at creation, is an alpha feature. So it's working, but in alpha. Depending on if you need that or not, you might want to use it or not. Okay, I also told you a little bit about the Rego and the Rego upskilling in particular. That has been quite long for me because even though they are built-in function, you still have to upskill. You have to get used to it, to know what you are doing. That's probably a language you don't know yet. But once you master it, then everything is okay. But you might not underestimate the time of upskilling. A few attention points on what's going to happen when you will deploy OPA. You probably have in your namespace third-party solution you installed using Helm chart. Those Helm chart don't know about the OPA governance policy you're going to set. So there are very few chances that they will be compliant. Which means that when they're going to restart, when you're going to upgrade those solutions, that will probably fail at some point, and you will have to modify it. Another thing is, if you're using a Kubernetes cloud managed service, then your AdmissionController can enter in conflict with theirs. In my case, when I want to upgrade the Kubernetes version of my cluster, well, the only solution I found is to stop OPA for a while, just the time to upgrade. So depending on your clouder, they might have or not a solution to propose you. The last thing is that you're choosing on which resource you want to apply your governance policy. So if you want to apply it on a pod, that means when you are going to do the deployment of the deployment resource, it's going to work. And then it's going to silently fail when the pod is going to show up in your cluster. Like you won't have a notification in your pipeline, for instance. So you have to check on that, and you have to find a workaround for that. Okay, the last theme is about security mechanism. When you have a look at OPA website, there is a tutorial to help you with authentication and authorization on endpoints. You can use that. That's very well done. But if you want to go further and, for instance, implement TLS encryption, you will have to do it by yourself because there is no native solution for that. Another thing is you might not want anyone in the cluster or any namespace to be able to communicate with OPA. Because if it does, then maybe it can change the config maps. Maybe it can change OPA's configuration. So I hope you listen very well to Vincent with the network policy, but because you will probably have that to put in place in your cluster for Opa namespace. All right. If you're trying to find another solution to Opa, there are some. The main one at the moment is Kyverno. So it's a much younger solution. It has been created by Nirmata in 2019, and it's also hosted at the Cloud Native Computing Foundation. It's an incubated project at the moment, so it's not as high as Opa is, but it's quite good. It's well followed by the community. We talked about all that at the Devoxx France a few months ago, so in April, and during this time, 1,000 people more just liked Kyverno GitHub repo, so it's well followed. The main difference is that it's Kubernetes native, so you won't be able to use it outside of Kubernetes. But the good news is that you don't have to use any code language to do that. You can use only custom resource definition. You won't have to learn Rego, you're just using CRD. The mutating is not an alpha feature like it is for Opa Gatekeeper. And there are a bunch of other things that are very nice, like you can generate reports, like audit your cluster and generate reports on what could happen if you actually deploy Kyverno within your cluster. You can also synchronize the configuration between namespaces. And that's a nice feature too. Okay, so I give you a link here with all the comparisons, which is like updated regularly. So you can check it. You can check it now. You can check it in a few months. And Kyverno is evolving very fast, so you will find some nice things on that. Okay, and now if you want to go further, I'm handing over to Ludo.
Thank you. So far, what we have done basically is that we have set up the condition to protect the cluster. We have set up constraints. We have isolated resources, access. We are mostly working on how we could prevent something from happening. But now we would like to detect when something wrong is happening and be alerted, right? If I take the metaphor of the castle, so far we have built a lot of things to protect the castle. But what is happening if someone is breaking in the castle? How can we prevent it from that? So moving from prevention to detection. And the way we can do that is maybe by monitoring the activities, okay? For example, what I would like to do is to analyze the processes, analyze the manipulation happening on the file system, and to detect some weird behavior that could highlight that something wrong is happening. If I take a specific example, what I would like to monitor. For instance, I would like to be alerted when, for example, a shell is executed on a container in a production cluster, because it's a very, very weird case. Normally in production, we shouldn't be able to shell inside a container. Again, if in the container a sensitive file is accessed, I would like to be warned, because again, it doesn't feel right. So the idea is to kind of look at the behavior and be able to trigger some alerts. I would like to do that as well on the cluster level. Not only on the container level, but if something wrong is happening as well in Kubernetes. For example, if a service account is created in some weird area of the cluster, I would like to be warned. There is no way somebody would like to create a service account in kubesystem. It doesn't feel right. And finally, I would like as well to monitor activities regarding the applications. Today, we all use Elasticsearch, Kafka, RabbitMQ. We know these solutions. We know what they are supposed to do and what they are not supposed to do. Meaning that if suddenly a very like exotic port is open on one of these containers, maybe something is weird. If, for example, a sensitive file for this like container is like open, modify, touch, again, something is weird, and we would like to be alerted. The way we can do that is from low-tech to maybe high-tech, okay? The first thing, we could like maybe log every command line executed on the container level. Pretty like hard to do, but we can just like set up that. We will need to collect all the logs. Somehow we can do some pattern matching. So possibly it could work, but a lot of work, I guess. We could use some like HEDS, host intrusion detection system, with solution like OZEC or WASUF, who will also inspect the activities and find some patterns. When something weird is happening, I can send an alert. And finally, at this level and as part of this session, I would like to focus on Falco. Falco is a tool that helps us to monitor activity directly at container level and on Kubernetes level. It's called a container runtime analysis. It's a multi-threat detection engine because it can like work at the container level. Something is happening inside my container, but also something weird is happening at the Kubernetes level. It's been created by SysDic and very quickly was distributed among the CNCF as an incubated project, which is kind of cool, okay? It was created first by a company, but now it belongs to the community. How is it working? Falco basically will have a set of rules. We'll give rule to Falco. And Falco will receive events as an input. He will receive events coming from containers. He will receive events from audit Kubernetes logs. And based on this input and the rule, he will trigger some alerts using one of the output channels. It can be std out, it can be an HTTP call, it can call maybe an external program. If we look into details, the way it works, when you run today a container, you will generate some sys call, meaning that when, for example, you start a container, you will work with the namespaces of the host to allocate some space, to allocate some resources. All of these are producing syscall. The syscall, Falco are gonna listen to them. He's gonna like poll this event in order to process them. The way he do that is using two different approaches. We can use a kernel module, or we can use the eBPF prop. A kernel module means that we will extend the kernel by installing a driver, for example, but we need to own the machine. There is no way, if you run something on AWS, you can install a kernel module. There is no way. You need to own the machine. So if you are doing on-premise, maybe you can do like kernel module. eBPF, on the other hand, is like extended bucket packet filter. It's a kind of like small virtual machine really close to the kernel in which we can push some code dynamically. It's really used in the observability world, especially when we want run some network analysis, like Wireshark, but it can be used as well by Falco to fetch the event coming from the kernel. With this event, I will go to the core of Falco using two kinds of library. I won't go in details. And then finally, I will reach the rule engine. It means that starting from now, Falco is receiving the events, and he's able to match using the rules. If something weird is happening, he will trigger an alert. Falco is also able to receive the Kubernetes event, meaning we are able as well to define rule when a behavior, an action is happening at the Kubernetes level. And recently, they also introduced the ability to implement our own source of event using plugin. It's been like deployed 1 or 2 versions ago. It means that in the future, we could also like implement some kind of SDK in which we will put and forward to Falco events from our applications. And we could leverage Falco to trigger events and alerts based on the behavior of the application. Suddenly we create 10,000 users. Something is weird. Maybe we should check. How do we install and deploy Falco? There is two ways. Either we run Falco directly on the host, meaning that I will just like install the package on the machine, but it means that I need to own the machine again. The other way is to use Kubernetes. We can deploy Falco as a container in a daemon set mode. It will be deployed on every machine. It's also interesting. Should we do one or the other? Depend of if you own the machine, and also it will have some benefits and disadvantages as well. If you run Falco on the machine, you are kind of out of the context of Kubernetes, meaning that if, for example, somebody managed to escalate the cluster, Falco is still out of these pictures and can still trigger alerts, right? The problem is that you need to make sure that these instances are working as permanently, right? It means that if suddenly the Falco binary is like going down, you need to have a failover mechanism that you need to handle on your own. While if you are using Kubernetes, you know, like me, that if the pod goes down, it will be automatically relaunched. So depending on which cases you want to cover, you will go with one or the other strategy. Falco objects. Like I mentioned before, the primary structure object of Falco is what we call a rule. So basically, we will define a rule as a set of conditions that will trigger an alert. Okay? I will give you an example in the next slides. So we are going to define a set of rules, and we can also use macro that will transform this rule to make it reusable. The idea is that once we have a set of rules, I can assemble them to turn it into a macro that will be a more high-level rule. And I can also do that with lists, meaning that I can list, for example, a set of rules that will be applied together. Okay? If we look at an example here, I have the open read. It's a macro, meaning it's a combination of different elements. And in the condition here, I have exactly the event system. Okay? It's a weird kind of, how can I say, condition. If we don't know event system, it can sound a little bit weird. But this is exactly the kind of event that Falco receives that we need to match against to identify this behavior. Here, we are detecting that a file is open read. Okay? The second line is the list, the concept that I described before, in which we list the shell binaries, because of course, depending on which container you run, the shell might be different. And finally, we have an example of a rule that contains the name, the description, and a set of conditions. And with this rule, we detect that a terminal has been executed inside a container. So it might be tricky to kind of like spend time understanding the events, trying to create your own rules. Fortunately, Falco comes with his already like predefined rules that we can use directly. Okay? Depending on which area you want to target, if you want to take a look at the file system, there are already rules that you can use. If you want to check at the network, already existing process as well. So in the case of, for example, your application, if your application is exposed on the, let's say, 8080 port, there is no way that your application suddenly is using a different port. So you can use, for example, Falco to say, hey, if somebody like suddenly changed the port or a connection is happening on a different port that's the one expected, I want to be alerted. This is exactly the example we have with Elasticsearch. We defined a set of allowed public ports that we can use. And in case, for example, we don't use one of these ports, we want to be alerted. Same is happening with a set of processes that are expected to happen in Elasticsearch. Elasticsearch is like running a lot on Java and the JVM. If suddenly we have like a PHP process inside a container, maybe something weird is happening and we should be alerted. Again, a set of existing rules already exists for different very popular applications. And Nginx, Traffic, HR Proxy, Kafka, Redis. So we can also make use of this rule to enrich a bit the way we observe our application. Now that we have seen at the container and application level, remember what I mentioned before is that we can also do that at the Kubernetes level. Here, for example, we will receive the audit log. The audit log API in Kubernetes is the way to listen to every event that is happening to Kubernetes in order to store this event somewhere, or in this case, to analyze them. Okay? So we will receive these events. Every time someone is like doing something on the cluster, we will receive this event, and we are able to define a set of rules. For example, here we can define using this event that we have a set of allowed namespaces, and suddenly somebody is creating a privilege pod out of these allowed namespaces. It can be an interesting use case. Now that we have done that, we would like to broadcast alerts. It's cool to trigger alerts, but we would like to broadcast them. We can rely on your existing strategy. If you are already like collecting logs on the std-out, you can keep doing that. We can maybe plug a Kafka or directly Elasticsearch on it. And basically, you already have the starting point to have a proper alerting system. You can also do something a little bit different with a project called Falco Psychic. And this Falco Psychic is actually an aggregator. It's a kind of like generic connector that allows you to connect the Falco alerts to many, many different channels. We can still push to Elasticsearch, to Kafka, but we can also push these alerts directly to Slack, Teams, Mattermost. We can push that to OpenFaaS, and Sidekick comes with his own web UI. There is almost like 40 different connectors, meaning you don't have to implement them yourself. And this is kind of interesting to actually forward all these alerts to your dedicated organization. Of course, because we are operating a system, we would like to monitor that using Elasticsearch and Kibana. And this is the kind of dashboard you would like to use. How many alerts? Which namespaces? Which kind of port? Which kind of users? At what time is it happening? And then we could like probably run some kind of analysis to define, in your team, we have received many alerts. Is it expected, guys? Can we work together and maybe try to improve and understand what is happening? Those alerts, are they happening at the container level or at the Kubernetes level? Is there any like seasonality? Is there any like root cause? We can do that if we properly set up from the beginning Elasticsearch and Kibana to be part of this analysis. And now I would like to share a demo, and I will switch the laptop. So I need an elevator music for like 30 seconds until I can change that. And I need the laptop after again. Cool. So I have on my laptop set up Falco, of course. So can we see the screen? Yeah, okay, great. Okay. So I am on my laptop. I have deployed a Minikube, which is running as a single node for the sake of the demonstration. And I will share with you a little bit what is happening. Is it big enough? Yeah, I think so. Okay. So I have deployed the Falco using mchart, and because I'm very like a strange guy, I deployed that in a namespace called Falco system. And what do we have in Falco system? We have 3 different pods. We have the Falco agent. Sorry. We have the Falco agent that is deployed as a daemon set. Because I have a single node, we only have 1 instances. I also have 2 instances of the Falco Sidekick. I have the backend part of Falco Sidekick that will receive the events, And I also have a UI that I will show you later that will allow us to visualize what is happening. Okay? Now I have deployed an Nginx because we are extremely creative. And what I would like to do is to get into this container, and I would like to trigger an alert from the Falco perspective. So what I'm going to do is that I'm going to exec inside it. Okay. Okay, I am selecting the bash. So very standard, I am inside a container, and what I would like to do is now go in the Falco and check the logs. Okay, so here I am back in the Falco container, and what we are doing here is that we are visualizing the logs of the Falco. Okay, and here Falco, he's listening to all events and is triggering actions. He's triggering some alerts based on the behavior he detected. And here, he noticed that somebody actually executed inside a container with a specific users in the default namespace. This is the pod Nginx, and we can also see what kind of command was executed, which is kind of cool. However, I won't be able to check the logs of every container every day. So what I would like to do instead is maybe having a first level of observability using this UI from Falco Sidekick UI. And here I have, for example, all the events that are properly organized based on their criticality and based on what is happening. This is kind of cool. I can go back. I can click on an event, for example, and I can have the details. I can also filter. So this is a pretty cool tool in which we can leverage the alerts and try to understand what is happening. Here, normally, I should have the terminal shell in container, which is here. And here I can see the event that has been triggered. And I can, of course, click on them and have more information. The interesting part here is that when I execute it inside a container, actually two things happened. First thing that happened is the container itself triggered this alert, but the second alert was triggered because I used the kubectl exec, which is a plugin from Kubernetes, which also will generate an event. This is why for this single action, I will have the two events in parallel and then two alerts. This tool is interesting. However, again, I won't look at it every day. So what I would like to do instead is whenever an alert is triggered, I would like to be notified. And okay, it's not sexy, but I am using Teams. And here I have set up a channel. And in this channel, I have this Sidekick agent. And we have a Deadpool here. And he's not super happy because we have a set of events that are triggered. Okay? Just to make sure it's really working, I will go back inside my container and I will do some nasty stuff. For example, I would like to update some packages, and then again, sounds a little bit weird to do that in production cluster. And if I go back here, the Falco Sidekick triggered an alert. And here, instead of dropping all the alerts to the Teams channel, I am selecting the criticality. I only want to trigger alerts to Teams if this is important. And if the level is, for example, the priority is called error. Because otherwise, I will just be dropped every second, every time something is happening. So we can also configure the criticality of the event depending on the channel we want to address inside Falco Sidekick, which is kind of interesting. If we take a look deeper here on what is happening, I can see, there is a package management process that was launched inside a container. I can have the command that was actually executed, which container, which images, which namespaces, which help a lot to understand what is happening. So this is pretty cool because it only takes me a couple of minutes to set up, and I already have something that we can use. If we go back here, what I forgot to mention as well is that Falco setkick does not have yet persistency. This is just a tool to visualize with a buffer of 200 events what is happening. Meaning that you will need anywhere to deploy Elasticsearch and Kibana if you want to run proper analysis in time. Because here, if I stop running that, it will just like forget all the events. No, not so great. So it's a tool really to connect. Here we can see all the inputs. I have a Teams input, I have webhook, I have the web UI. But then you still need to have Elasticsearch and Kibana or any other like observability tool to have this persistency. Okay? Finally, I would like to demo something a little bit different. I will explain the use case I would like to demo. So we are alerted, which is great, meaning that, okay, something happened in one container, I am alerted, so I can investigate. But wouldn't it not be great if I could automatically respond to this alert? Wouldn't it be great that we have a set of like primitives from Kubernetes that will be automatically triggered when some like behavior happening, without having someone to be wake up in the middle of the night to actually doing a couple of like actions. So here, what I would like to do is whenever somebody is executing inside a terminal, inside a container, is opening a terminal inside a container, I would like to just shut down for a couple of minutes any connection. And I don't want to do that manually. I want to have an automated process for doing that. And this is what I would like to demo, and I will explain how is it working. So the first thing we are going to do is like, I can still inspect my namespaces. I just have the Nginx. And now what I would like to do is I will run a pod called names web server. We are still big fan of Nginx, so I will deploy an Nginx, okay? And here, it should be deployed in a couple of seconds, okay? And what I want to do after that, so now that the web server is deployed, I will exec inside it. I can also describe, maybe just to make sure I'm not cheating, so I can describe the pod. This is just a standard web server. We don't have any specific like features. And now I want to exec inside this web server, and I would like to be blocked from doing anything like unauthorized, okay? So here I am inside, which is great. And now I want to try again to execute the package updates. And normally, if I have done my work, it should not work. Meaning that if I do apt-get updates, here I am timing out just because Falco has like detected this event and has automatically forbid any connection. The way it works is kind of interesting, and I will explain how is it working. So if you remember correctly, we have the concept in Kubernetes called NetworkPolicy that Vincent introduced. What I am doing is actually whenever somebody exec inside a container, I will assign a label to this container, and I will dynamically create a network policy that will deny the traffic for all this container. And the label, I call that suspicious activity. Meaning that now if I describe again the web server pod, okay, if I describe pod web server, I have now activity equal suspicious. This is a label that I dynamically set up after somebody executed inside this container. And now I also have a network policy here that was created like less than 2 minutes ago, and that will select all the pods that have this label activity equals suspicious, and that will put the pod in quarantine, meaning that we will like forbid any transactions, okay? And here, the net pol is actually what we already discovered before. There is nothing very fancy. I am just denying all incoming and outgoing traffic. Here, I am just matching the label, and basically I forbid everything. This is why this container is not able to fetch any dependency. We can also try, if we go back inside the pod, maybe to curl Google, and again, he will time out. Just thanks to this automated behavior that was introduced as a response of the alerts. No human have done anything. This is automatic. Okay? The way it works, it's because I have introduced a technology that is called Argo, and especially the Argo event stack that we can see here. And this Argo event stack is able to deploy a set of resources that we call sensor. And this stack is also able to talk directly to Kubernetes. Okay? So here, for example, what I have done. I have deployed what I call a sensor. Sorry. I have deployed what I call a sensor, and this sensor will actually expose an HTTP endpoint. Falco will forward all these events to this endpoint, and this endpoint will filter all the alerts sent by Falco, and he will filter them according to the type of alerts. For example, terminal shell in container. The rest, he will just forget them. What he will gonna do after that is gonna create here a network policy, just like I described. No egress, no ingress, and a match label called activity suspicious. Meaning that whenever I receive an alert coming from Falco that is named terminal in shell, I will dynamically create a network policy. And of course, for this action to work, I need to use the namespaces in which the alert was detected. And this is the purpose of the parameter. So here, I will read the Falco event as an input. I will extract the name of the namespaces, and I will reuse that so that in the namespace in which the alert was triggered, I will apply the network policy. Otherwise, there is no way it can work. The second action is I will patch the container that was actually triggering the alerts in order for this pod to receive the label activity equals suspicious. The way I am doing that is quite easy. I am patching the resource. In the patching, I'm defining that now label must be added, activity equals suspicious, and again, I am reusing this time two parameters. One, to specify the name of the pod that is targeted, and the second one is, again, the namespaces. Okay? So namespaces here and the name of the pod. Otherwise, of course, this is not going to work dynamically. Okay? So if I summarize, whenever somebody executes something in the container, then automatically we will create a network policy in the namespaces, and we will assign the label to put the pod in quarantine. It's interesting, but I think we could go even deeper to have a properly, how can I say, chain of response handling. Maybe that instead of that happening immediately, we could maybe set up a timeout of 5 minutes. If nobody acknowledges the alert, maybe then we can put the pod in quarantine. And maybe if after 30 minutes still nothing happened, we can maybe just kill the pod. But the idea would be maybe in a more advanced use cases to have this escalation in the way we handle the alerts. Opsgenie, for example, could be a solution to escalate step by step the action that we want to apply automatically on this pod to get rid of the need to involve some DevOps in the middle of the night because we have discovered that something weird is happening. Okay? All right. I've done with the demo, so I will need your laptop again to finish with Falco. So now, the way we deploy Falco in an organization is quite interesting. We're going to start probably by investigating about what do we have right now in the cluster. We need to start again with what Vincent presented. Try to understand what we have at the cluster level, and then after, try to set up the Falco. This is what we call the inventory practice, the inventory stage. Then we could probably deploy Falco as a first incubation phase 1, and we need to communicate with the developers. Guys, we are going to deploy Falco. This is a great tool. This is going to help us. At the beginning, it will be more like to warn us, but very soon we will provide you a couple of feedbacks to fix your deployments. And then after that, in the phase 2, we can collect the results, and we have to set up a couple of workshops with devs. Hey guys, we have noticed a set of weird alerts. Is it expected that your container is acting this way or not? And based on this feedback, we can improve incrementally the quality of the deployment to make sure that we get rid of the noise and we have properly efficient alerting. And what is interesting with Falco and that we need to leverage is we need to enforce. We receive a set of alerts, we try to analyze them, check with the developers, and maybe we can turn this alert into a rule. We can create an Airbag rule, a pod security admission. Maybe we will introduce a new network policy to make sure that these alerts will not happen again. And this way we can constantly improving the protection we have around our castle. So Falco can be also used to collect information and increase the level of defense we have in the cluster. We can also, of course, use Opa, right? We have identified a set of behavior thanks to Falco. Now we need to solve them in order to make sure they're not happening again. Of course, like any solution, Falco come with a set of limitation. If you use the default rule and you deploy that tomorrow, you will receive a lot of alerts because per default, Falco is checking a lot of things, and then you will probably receive a lot of noise. The second thing is that there is a kind of technical limitation. The way Falco processes events based on the kernel, it relies on a buffer, on a ring buffer, right? And of course, if suddenly I have a high number of events, some of them might be dropped. It means that if an attacker is able to generate a huge number of events on a specific node, maybe some of these events will be dropped, and then he will be able to hide his tracks. So this is something that the community is aware of. There is already a couple of strategy to make sure this is not happening, but this is something we need to be aware of. As well, if you have a very big cluster, of course this is not the case for everybody. Falco has limitation when we go above 400 nodes. This is not for everybody, but just to mention. And finally, because Falco is running on syscall, if suddenly you upgrade version of your machine, of your content runtime, and suddenly, for example, the way we initiate operation changes, of course, Falco won't be able to follow up. They are aware of that, but this is something we need to be aware when we upgrade the machine, when we upgrade the cluster, to make sure that Falco is kind of aligned with the new way of reserving some memory, reserving some space, opening a network connection. Couple of recommendations based on this limitation. Yeah, as a starting point, this is what we have done. Maybe you need to listen only a specific set of namespaces in container that really matters in order to avoid the noise. You can also start with a set of limited rules. What is also very important from the beginning is to structure collecting and store the alerts in a pipeline. Okay, Elasticsearch Kibana. From the beginning, this is very useful to understand where we are going. Otherwise, you will lack feedbacks to structure your approach. Finally, of course, you need to reuse as much as possible the existing rules. Okay? We have 13 minutes left, so I will drop a bit for the last part regarding how we can scan vulnerability contained into image. If we start again from the beginning, now the cluster is kind of safe. We have used like the primitives to actually like constrain the cluster. We have used Opa to go a little bit further and really customize what we are doing. We are now able as well to detect and not only to prevent what is happening, but we have still not taken into consideration what is happening if we have vulnerabilities in image we deploy. This is why we need to consider this approach. The way image scanning are working today is very, very straightforward. We have like a tool called image scanner. He will like rely on vulnerability databases. This vulnerability database will fetch actually a set of like data, CVE, to actually like build a library of vulnerabilities. And this image scanner will kind of decompile the image, inspecting the packages installed, the version. Some of these like images will also take a look at the code, scanning, for example, the Gradle, the Maven, the Composer JSON, and we'll check as well if the code contained in the image has some like vulnerabilities. Of course, depending on the image size, it may take time to execute. We may have some teams that are not very familiar with that, but recently on some projects, we have some images that are nearly like more than 1 gigabits, and then, of course, it can take time to analyze. And we need also to upgrade very regularly the databases, which is very obvious. But for very specific cases that we had with customer, when you are running on like air-gap environments, completely disconnected from internet, this is becoming challenging. A lot of solution exists. I will only share with you two that we recently used. Clair, who was initially introduced by CoreOS, who was acquired by Red Hat, who was acquired by IBM, and it's a pretty like cool project. It's already integrated with different artifact management solution, meaning that, for example, if you use GitLab, Quay, or Arbor, Clair is already installed, and when you push the image to the registry, it will automatically analyze the vulnerability contained inside it, which is kind of like interesting. It already works with different sources, so this is also quite good. A second tool that is interesting as well, again from Aqua Security, is Trivy. Trivy is a little bit different because you can use it directly in command line, which is very good, while with Clair, you need to deploy a server, a databases that will fetch the dependency, so you have to work a little bit on your own. For Trivy, it's allow as well to analyze the dependency of the application, and then we go as well with the does this image contain any vulnerability, meaning the base image, and the application containing as well vulnerabilities. The way we integrate that is not very creative as well. We will use the CI/CD pipeline, and one of the stage will be to properly analyze the image. In case we have like high number of vulnerability, maybe we could drop the pipelines, and then we need to rework a little bit the code. If we are good, then we can move further. How does it fit in terms of strategy? Like I mentioned, if you are using, for example, a registry that already comes with his own like scanning solution, it can be interesting because in the repo, we will analyze the image that has been pushed. So it's not part of the CI pipeline, it's mostly part of the registry itself, which come with proper integration. I can, for example, open a ticket saying like, hey, in Arbor, we have this core, it's not so great, can you please do something? And what can be interesting is like we can mix the two. Maybe we can use one tool as part of the CI/CD to analyze the image. Maybe we can also reuse in parallel, in combination, another scanning image as part of the registry. So we have maybe a broader coverage in terms of vulnerability analysis. In terms of recommendation, yes, update vulnerability every day. It sounds quite like logical. Like I mentioned, we can rely on multiple scanners to increase the detection coverage. Can be interesting. When we have money, time, and teams, it happens from time to time. We can have also like a team that is responsible to build and share reliable catalog images, meaning that it's not only the responsibility of the team to build proper images, but we can have like a shared team that will really spend time to build quality images. It may happen in very sensitive area, banks, pharmaceutics, defense area as well. Sometimes we may need as well to inspect third-party images because the images is provided by somebody else. I'm not able to manually create this image. I can use a tool that is cool. It's called Dive. And Dive will allow you to actually also understand how the image was built, what are the steps, what kind of dependency I have in this image, which is sometimes interesting because nowadays the container is becoming the per default delivery package, let's say. Finally, when you are in Vents as well, you can use some image signing feature, and you could potentially restrict the Kubernetes deployment to deploy only signed image with projects called Notary, for example. So the idea is really to entrust the fact that this image is really coming from where it said it comes, and that this image has been approved according to a set of quality check. For example, the image has been checked in terms of vulnerability. In conclusion of this very long session, we have audits the Kubernetes configuration. This is important. We can't just trust what people say to us, especially nowadays that we are more and more involved in legacy Kubernetes cluster, in which there is no documentation, in which we don't know how this Kubernetes was set up, and then we need to really audit from scratch what do we have, how it was set up, and then the tools that we have introduced are quite interesting and maintained. Kubench, Kubenter, Popeye, Kubescape as well, we haven't mentioned about it, but kind of interesting tool. The second part is that we don't need to reinvent the wheel. Kubernetes already comes with a set of very rich primitives that we need to understand, leverage. And maybe because this is also very kind of like low level, we can rely to go a little bit further on PaaS solution with OpenShift, with Rancher, for example, because these solutions are able to provide higher abstraction to manipulate the core object of Kubernetes. With Rancher, with OpenShift, I can create group of users with very like defined permission, and this is quite cool. And of course, they are relying on the Kubernetes Airbag for doing that, but they provide higher abstractions that help us to save time and be quite efficient. They also provide connector to external directories in which we can fetch, for example, a set of predefined permission. If we want to do that on an organization layer, instead of having permission in every application, maybe we can centralize that somewhere, and the Kubernetes will just like keep aligned with this set of permission defined at the organization level. And from time to time, if you want to, you can rely on extra tooling. This is what we try to propose with Opa and Falco. Of course, in 3 hours, we can't like just say we have covered everything. It's not the case. Okay, so there is other security dimension that we need to explore. I briefly mentioned before about the gvisor, which is a sandbox container runtime. It means that gvisor will provide, for example, a new container runtime that you can use. So, for example, you will have a node. Okay, and some nodes of your Kubernetes cluster will have this sandbox called gvisor, and it will allow you to run container that you don't really trust, that needs to be run as a root, but you will have this sandbox environment. Basically, gvisor are re-implementing an extra layer on top of the kernel of the host, meaning the container can still run as a root, but he will be kind of really contained in this sandbox. So it's kind of tricky to set up. We spend a lot of time, but it might worth it if you are really running something you don't trust and you can't do otherwise. Kubernetes as well, I guess you know, there is no proper secret management solution. The secrets, they are just encoded, they are not encrypted. And then as soon as you are gonna use secret in Kubernetes, you need to spend time to invest to some vault solution. So I mentioned about vault, it can be any other solution, but this is something you need to tackle from the beginning as well. Kubernetes does not have a backup strategy as well. If you are running your Kubernetes on-premise, it can be interesting to use Velero to actually back up your etcd, to back up your control plane, your data plane, the status of your container. It can be interesting. Another solution that came out very recently is called vCluster. It's a solution that allows to run Kubernetes inside Kubernetes. It means that basically I will create a namespace in a master Kubernetes, and inside it I will deploy a small control plane that the users can use to create their own resources, but they will be still constrained in these namespaces. So it's kind of interesting because instead of spending a lot of time on Airbag, maybe especially in dev cluster, we can just like say, okay, you are admin of your own like small Kubernetes cluster, but it will be namespace anyway, and we can just like get rid of that, and all the deployment will be destroyed as well. So it sounds interesting. We have not tested it, but I read the documentation, and it sounds pretty cool. We have talked a lot about how do we secure Kubernetes, but what about the workload that run inside Kubernetes? Most of the time, especially when we are doing microservices application inside Kubernetes, we will like a couple of features. How do we do, for example, end-to-end encryptions? How do we include some higher control in the exchange between the application? Not only allowing using like NetworkPolicy, but how we can encrypt. Istio is a service mesh, allowing us to implement MTLS and allowing us to implement zero trust network, meaning we can provide, for example, the ability for two applications to talk to each other inside Kubernetes with proper decent encryption, which is interesting. And Istio comes as well with a couple of extra features. We can do observability with distributed tracing, and we can set up as well a very fine control deployment strategy, Blue, Green, and Canary for them. And finally, we can also think about GitOps as an opportunity to secure a Kubernetes cluster. With GitOps, the cluster will listen to a repository to stay in sync, meaning that I don't need to have access to the cluster to deploy anymore. It means that nobody has to access the cluster anymore, because the cluster will listen the repository in which I will push my code to configure the deployments, meaning somehow I am reducing the attack surface of the cluster because nobody needs to access the cluster. I don't have to spend time on the writes. Maybe the repository is enough. As long as you have write permission of the repository, you will be able to deploy in Kubernetes. Can be interesting in some cases. As a final conclusion, we would like to share with you a couple of resources that help us to actually achieve this approach during the past couple of years. There is a very great book called Kubernetes Security that was also like contributed a lot by people from Aqua Security, which is super interesting to read. There is the CIS that we mentioned about, which is a little bit long to read regarding how we can like secure a Kubernetes like configuration. And more interesting, recently the NSA also published a guide to actually like secure more the Kubernetes cluster by introducing a set of like rule and auditing strategy. Some of the content of these reports is kind of like overlapping with the CIS, but this is still interesting to have a different overview on different risk level as well. So the time is up and we have finished this session. Thanks a lot for listening to us. And if you have any question, we will be happy to answer them with a drink a little bit later. Thank you very much.